value of k for which the system is critically damped. Okay, we have to find the gain k for which the system is critically damped. Okay, he has given g of s and h of s is equal to k by, okay, I can write this one as g of s h of s is equal to k by, what is this one, s into s plus 5 into s plus 10. So this is equal to s square plus 5s into s plus 10. Okay, now this is equal to s cube plus 15s square plus 50 into s. Now what is the characteristic equation? Characteristic equation is given as s cube plus 15s square plus 50s plus k is equal to 0. Okay, this is the characteristic equation. Now what is dk by ds? Dk by ds is equal to, we have to derive this k with respect to s. So this is d by ds times of minus s cube minus 15s square minus 50s. Okay, now where the value of zeta is equal to 1 be there in root locus. Okay, the only method is to find breakpoint in root locus at zeta equal to 1 is at breakpoint. Okay, that is at break-in point. If you see here the root locus plot, this is s equal to 0. Let us take, this is a point at s is equal to minus 5, and this is a point at s equal to minus 10, so on up to infinity. Now this is the branch which lies on root locus, and this will be the branch, another branch which is going to lie on root locus. Now zeta equal to 1, we have to find the value of k for which system is critically damped. That means value of k for which zeta equal to 1. Okay, it is zeta equal to 1 will be there only at breakpoints. Okay, you can remember this point at zeta equal to 1. That means we have to find at breakpoint. Now where can be the breakpoint? When two poles lies consecutively on root locus, then we can say that we have one breakpoint. Okay, how many number of asymptotes are possible here? Number of asymptotes are n minus m, that is number of poles minus number of zeros. Here we have 3 asymptotes. This pole 10, okay, this asymptote will be along this 180 degrees axis. You can also calculate plus or minus 180 by 2q plus 1 into 180 by n minus m. This will be the asymptote angles, which is equal to 60 degrees, 180 degrees and 300 degrees. That means we have a break away point here, since two poles are consecutively on the root locus. If two zeros are consecutively on the root locus, then we can say we have one break-in point. Here we have one breakaway point. That means now this breakaway point, that means these two poles will go along this breakaway point to meet asymptote at infinity, that is 0 at infinity. Now what is dk by ds? Dk by ds is given as 3 times of s square, derivative with respect to s, that characteristic equation. So this is minus 3 square minus 30s minus 50 is equal to 0. From this we can find that s is equal to minus 2.432 and minus 7.886. If you see here, minus 7.886 point, which lies between 5 and 10, this branch does not lies on root locus. That means we have to not consider this minus 7.886 point. So what is the value of s here? S is equal to minus 2.432. Now what is the value of k? K is equal to minus s into s plus 5 into s plus 10. Or you can define as the value of k at s, this is at poles, divided by at zeros. Okay, since we don't have zeros, consider only denominator as 1. So what is the numerator part? Numerator part is equal to this one. So what is the k value here? K value will be approximately around 48. So option gain k is equal to 48 is the answer. Option B is correct answer. If a system has a Bode plot with a constant slope of minus 60 dB per decade for all frequencies. What is the phase margin for the system? Okay, phase margin is given as 180 plus angle of the system. Okay, G of s and H of s. He has given it is having a constant slope of minus 60 dB per decade. Okay, now minus 60 dB per decade means, okay, since we are having minus sign, that means we have poles. Okay, 60 dB per decade means number of poles is equal to 3 because each pole has minus 20 dB per decade. Okay, if you have 3 poles at origin, what does it mean? That it is having the function 1 by s cube. Okay, that means minus 3 times of tan inverse of s. Okay, now what is the phase margin here? At gain crossover frequency we have phase margin, so this is minus 270 plus 180, or you can say that 180 minus 270. Okay, minus 90 degrees is the answer. That is option C.
The given figure for an order. Here it is starting in the third quadrant, means it is type 1 and it is extended into the third as well as fourth, third as well as second. So it is in order 3, that is because one pole at origin and two non-zero poles. So order 3, that is option C, is correct.
Receiver has an antenna with a total noise temperature of 50 K and the physical temperature of 300 Kelvin and an efficiency of 99%. Its transmission line has a physical temperature of 300 Kelvin and efficiency of 90%. The first 3 stages of receiver all have 80 K noise temperature and 13 dB gain. The receiver noise temperature is, here receiver noise temperature is nothing but 80 plus 80 divided by 20 plus 80 divided by 20 square is equals to 84.2 Kelvin. Here this is gain is nothing but given in dB. So 13 is equals to 10 log G. So which is nothing but G is approximately equals to 20. So C is correct. The system noise temperature at the antenna is. So system noise temperature is nothing but ambient temperature, antenna temperature, ambient temperature and efficiency of an antenna minus plus transmission line temperature 1 by ETL minus 1 plus 1 by ETL into temperature of the receiver. So if we substitute all the values we will get this as a 180 Kelvin. That is option B is correct.
Here the circuit is given in the figure. We have to decide what kind of function it's going to perform, whether it is going to perform decoder or encoding or multiplexing or demultiplexing. See here, if A1, depending upon the A1 and A0, D3 or D2 or D1 or D0 are going to be passed. Only one of those are going to be passed, means it is acts as a selection lines. So it is a multiplexer. So option C is correct. Comes to value of f, if A1 both are equals to 1 means C3 is going to be 1. So D3 is going to be passed to the F. So option C is correct.